The next section that we're going to look at is solving exponential equations. Now this first problem that you've got on your sheet, 4 to the x is equal to 56, I'm going to solve this in many different ways. We're going to check our answer and then also verify it graphically on the graphing calculator. So I'm going to show you all these different ways. Don't feel like you've got to use every single one of these ways each time. Just choose the one that works best for you. So here, 4 to the x is equal to 56. The first approach that we could take is we could take the same logarithm to both sides. So if I have 4 to the x is equal to 56, since this equation here has a base of 4, this exponential, I can take log base 4 to both sides. So log base 4 of 4x is equal to log base 4 of 56. The reason I chose log base 4 is because here on this left-hand side, log base 4 and 4 simplifies down to 1. That's one of the properties of logarithms we looked at a couple chapters ago. So now on the left-hand side, since I've got this logarithm that's got a power, I can roll this x out in front. X times log base 4 of 4 is equal to log base 4 of 56. Here log base 4 of 4 is equal to 1. So I'm left with log base 4 of 56. I can then finish simplifying this by plugging log base 4 of 56 in my graphing calculator, or I can use the change of base formula, which means I write each piece of the log as its own separate base 10 log, and then log of 56 divided by log of 4 is approximately 2.904 rounded to 3 decimal places. So that's one way that we can solve this equation, taking log base 4 to both sides. The second approach we can take is by converting to a logarithmic form right off the bat. So here, 4 to the x is equal to 56. Let's convert to logarithmic form. We know the answer to the log is going to be the exponent. We know that the base of my exponent is the same as the base of the log, and then that other answer is just the other piece that goes there. Now you can see right here I'm to the exact same point that I was in my previous problem, just in a lot less steps. So log of 56 divided by log of 4 with that change of base formula, which is once again going to be about 2.904. The third way we can go about doing this, and this is probably the way you did it in college algebra, is you took a natural log to both sides. So 4 to the x is equal to 56. Take the natural log to both sides. So the natural log of 4 raised to the x is equal to the natural log of 56. Your power property once again says you can bring your exponent out front. And then finally get x by itself. We divide both sides by the natural log of 4. Natural log of 56, just confirm this in your calculator, that's the same as the others. Natural log of 56 divided by the natural log of 4 is going to be 2.904 as well. So all three of those ways are perfectly legitimate in solving exponential equations. Choose the one that works best for you. Now in order to check this, we would plug our x value back into the original. So coming back up here, we'll do a quick check. And my original 4 to the x is equal to 56. And if I plug in my value, 4 raised to the 2.903677461, if I use the full value that I have in my calculator, and that you will see 56 does equal 56. So that does work out. This number right here is a great number to store in your calculator as you're working or to recall when you do a check. If not, you can type in as many decimal places as you see on your screen. Rounding might not give you an exact answer. You might see 55.2 is equal to 56 if you decide to round this answer too soon. The final thing I want to look at with this problem is how would we verify this graphically on the calculator? And the way we would do that is we use a little bit of intuition here. Here's my graphing calculator, and you learned about the intersect feature last year. We're going to take each side of the equation and set them in a separate y1 and y2 expression. We'll change our window and then use the intersect feature under the calculation menu. So let's start by typing in 4 to the x and 56 as my two values. Left hand side goes into y1, the right hand side goes into y2. And if I hit graph right now, I'm not going to get a lot of information. I'm going to see the first part of the graph go up, but this window right now isn't set high enough to see the y equals 56. This is only, if we go up to window, only 10 units high. The y max is 10. So what we need to do is we need to be a little smart in how we set up our window here. So if I go back to my original problem, I know that in my graph, I set y1 equaling to 4 to the x and y2 equaling 56. And the goal that I want to have is the intersection of these two graphs. So I'm going to have something that looks like this, and I want to find that intersection point. Now I know since y equals 2 is a constant function at 56, that this value up here has to be 56. So I've got to change my window so that I can see 56. The other thing is that I think that my x value is going to be 2.904 based off of all the numbers that I got here. So here I've got to be able to have 2.904. So maybe a good window to have would be something a little bit larger than 56 and a little bit larger than 2.904, and then we'll set the scales to be 1/10. So going back to our calculator, I know that my exponential is never going to be negative in terms of what I'm looking at. So let's set my x min as being 0. I think my x max has to fall between 0 and 2.904. So let's make it 5. That's bigger than 2.904. And then if I go 1/10 of that, my x scale will be 0.5. Y min, I know my value is never going to be less than 0. So let's set that as 0. My max, I know I have to hit that y equals 56 line. So let's make this y equals 80, just so we've got enough room. And then the y scale will be 1/10 of that, which will be 8. So if I hit graph now, I've changed my scales, and I can see my two equations intersecting. To confirm that that intersection really is 2.904 and 56, we go to Second, Calc, and then choose option 5, which is intersect. And then you'll be asked where the first curve and second curve intersect. Go as close as you can to the intersection point. Hit enter 3 times. And then you can see right there the intersection is 2.903 and then 56, which confirms our answers that we had.